Hey everybody, so today the demo I'm going to show you is just trying to give you an explanation of what these quads are, what edge flow is, what topology is, and why it's so important in a good model. Now, this is kind of the three things I've been talking about. I brought them up before, but there's a triangle, a square, and a pentagon. And in computer graphics, we're going to call these tris for triangles, quads, because it's anything that's four-sided, no matter what the kind of shape is, it's still a quad. And this little pentagram is an n-gon because it has n number of sides. Any number of sides more than 4 is considered an n-gon, but for our purposes, we usually say 5 because we generally don't want more than 5 sides, and I'll show you in a second. Generally, we use these quads. They're like the good ones. They're the ones that work really well for us. In fact, most of the tools you've been using automatically generate these squares that we're going to call quads. You might have noticed that already. Well, let's go ahead and take a look really quick at a grid. And I can demonstrate some of this for you as we're going through. So most of the time, we see these big grid marks of lines like this. A big like grid paper, and if you hold Alt and click on any of these directions, or we can do it too, Alt and click on any of these with my edge or face selection, we see we get a continuous line, and this is called a loop. In this case, this is an edge loop, and when it's with faces, it's a face loop. And we know it's a full loop because when we click it, it automatically, with Alt, it'll automatically let us select all of the other ones. This is because Blender understands when I'm going which is the next logical one in the sequence. It doesn't make circles like this because, well, why would it? It doesn't make any sense to it. However, sometimes we want to use these loops to control the direction of something. Sometimes we don't want a loop to go on forever. If, for instance, I delete some edges or faces in this case, and we can see now that when I try to make this line, it stops at the top and the bottom. This can't go any further because it hits a hole and it doesn't know how to go. At the same time, if I take something like this right here, I've now created a triangle, and similarly, it comes to the point in the middle. And any of these places it gets into, it doesn't know where to go with it because it's sort of chained them all together. So I'm going to merge this all together, and we can see if I kind of collapse all these, we have a continuous line here, but it stops there because this triangle stops it. And if I create, in this case, something like an n-gon, so I'm going to dissolve this edge, I'm going to get rid of all of these edges, and now I have a 5-sided. Whether or not this is pointing or not, it's still 5-sided. This also stops these loops. We can use this to our advantage by controlling the direction something goes. For instance, let's say I want to create something like a mouth or an eye which has opening or deformation to it. Well, I don't want the loops going straight. I want them to be able to turn around in the surface. Because if we think about it, the mouth, it's kind of like a rubber band. It should form, it should deform. The eye should be able to open and close. We do this by creating like a little selection here. So if I created a group here, and I created an inset, and then maybe even another inset, you'll notice something happened. I still have a bunch of quads everywhere. I still have 4-sided objects, but if I create new loops in things, it runs around the circle. It runs around the surface like so. And now my selection, instead of running up and down, runs in a little circle. This is because we're using what are called poles. Right down here, we've got 2 poles. So right here, we can see that this regular vert that we're normally looking at connects to 1, 2, 3, 4 different verts. This one, however, connects to 1, 2, 3, 4, 5 verts. And this one only connects to 1, 2, 3 different verts. This one right here is called a 3 vert. Sometimes it's called an N pole, but it's basically a 3-sided pole. This one right here is a 5-sided pole, and the effect that they have is almost like gravity, where the 3-sided one sort of pulls the form around it, pulls things closer together. The 5-sided one pushes it away. We could use this to redirect how something flows. So this is when I was doing the demo and making the shirt, and I said I want to make a collar because I want the geometry to flow around it, so that if I have something like a hole at the center, like this whole guy here, can actually deform much, much more easily because it creates a nice little loop. It creates a nice circle running through it, a circle of contiguous edges. And that's something a computer can do really well to form and deform. So we want a nice long loop running along like arms. So we want loops running around and connecting back into each other, like on a tube. But we also want loops running around places like the mouth or places that we're going to form. Now, this is also something that we can do to, like, when we want to put these things together, we can, if we look at it as like a three-dimensional shape, you'll see when we lift it, it does something similar. So if I do an extrusion here, we get a similar effect. We've actually got a 5-pole and a 3-pole. So when you're extruding and moving stuff, without even realizing it, you're creating the same relationship. And they have to go together. We can't have really a 3-pole without a 5-pole. We can't have a 5-pole without a 3-pole. And there's a kind of conservation to it. If all of these connect to 4, this one connects to 3, this one connects to 5, do the math. 3 plus 5 together adds up to 8. 4 plus 4 adds up to 8. There's a conservation of how many connections there are to go around. What this means is that we can use this to help us shape or redirect things. So we can see here, here's a human head as an example. And you can see the places that like a 5-sided pole is, and somewhere up here is always going to be a 3-sided pole that connects it together. But most importantly, all of the shapes on here are quads. They're all squares. And we use these little poles in the different corners here to redirect our turns so that we can run around the eye, but we can also get a line running along the head. But we can also get a line running along the mouth and above the nose, which helps to form that. We can also get lines that run around the mouth and the lips. We can also get lines that run back and into the ear. And you'll notice that often on these models, especially face models, have a ton of these loops that all run inside the eye because we have the eyeball covering it up, and this is often just a hole right in there. And this kind of thing is really important, especially when you're modeling characters, this sort of topology. Often, this is kind of like pushing things around. I like to think about this almost like water. Like, I can't make it smaller, I can't make it bigger, but I can push it around. I need to push the connections between these verts around. We don't want something that's purely flat, that's kind of quad dividing like we've been doing with the Retopo tool. This is why we want to do it by hand, because only we can tell the computer where the loops need to run around to get a good deformation, a good sense of the form to flow around the surface. So next video, tomorrow, I'm going to show you how we can use those retopology tools I showed you yesterday to redirect some of these shapes, to redirect the flow, and to retopologize something like a face or a body.